All right, so here we are getting into angles, section 1.5, getting pretty close to the end of the chapter actually. So, angles, you're probably going to be a little familiar with angles to some extent, but now we're just going to get into specific parts, how to name them throughout geometry, and then the different types of angles that you're going to see. So, parts of angles. You've got like a typical angle right here. I'll just go A, B, C. And you've got an interior. There's your interior. And your exterior. Now the different parts of this angle, you have a side, and you have a point. The point, remember we call that the vertex. We have the other side here. And we're going to use these names, side, vertex, and side, when we name this particular angle. So when you name an angle, you're going to use 3 points most of the time. And you're going to use the pattern side, vertex, side. Such that if you were to trace this, similar to naming a polygon, if you trace the side, vertex, and side, you will end up with the same angle. For example, this particular angle, we could call it angle ABC, ABC, because you're going from A to B to C. You'll notice, there's your bounce, ABC, side, vertex, side. Or you could go CBA. Okay, and this little symbol is your angle symbol. It looks like you're greater than, less than. If you remember that, the hungry gator from Inequalities. This can be used as your angle symbol. You know what? One other way you can name an angle is just to use the vertex. I gotta remember that. So you may use vertex alone. Alone to name your angle. So this would be angle B. That's going to work sometimes, but just not all the time. Because if you have multiple angles around the same vertex, you have to specify which particular one you're talking about. Again, you will see some of those in our examples, but just be aware you can use, or you might be asked about a particular angle using only one letter. If so, then that is your vertex angle. Okay? Now, types of angles. You have an acute. You guys remember what those are? Angle less than 90 degrees. 90, you can kind of make an L with your fingers. 90, that's a 90. So less than 90 would be something where you're kind of getting squishing the L. Then we have our obtuse angles. Obtuse angles are something bigger than 90. We have right angles. These are exactly 90 degrees. Put a little box in there. Remember, that's your 90-degree angle marking. And we have a straight angle. straight angle is a straight line. It's exactly 180 degrees, a line. Okay. So you're going to use those types of angles just with general classification of angles. And let me turn to the next page here. Boom. So next page, this is going to look familiar, I think, because you've already seen it. It's your angle addition postulate. And your angle addition postulate is very similar to your segment addition postulate. Remember that was part plus part equals whole, because you're going to use the same format. But now you're going to be using angles. So if I was to go like this, let's go A, B, C, D. So with this particular angle, I can say part plus part equals whole. And let's see, this top part, that top angle would be ABD. So I can say angle ABD plus angle DBC is congruent to angle, the full angle, ABC. So you'll notice if I totally erase that angle in the middle, I've got an ABC situation. Cool. And you can use it, you'll be using this with angle measures and numbers, and solving them with a little bit of algebra. Again, check out the examples video for those, but for now just get this in your notes. And we got the angle addition postulate. We're also going to have bisecting angles, but before I get into that, I want to talk about the different types of congruent angles that you might see the markings. Remember yesterday in polygons we talked about how a little arc in the corner is how you can tell if angles are congruent or the same. So you're going to see a couple ways. So yesterday we talked about this one. Boom, boom. Hey, same arc. Yep. Those angles would be the same. We know that because they have the same arc measure there, or the same little marking. Another thing you might see, and I just don't want you to get confused by it, if you're talking about multiple angles, these guys could be the same, and these guys could be the same. So you'll notice you got two different sets of congruent line or congruent angles. So these angles right here are the same, so you mark them with one tick. These angles right here are the same, so you mark them with two ticks or two arcs. Okay? So just recognize that. If a couple arcs have the same measure, they're the same. But my one arc is clearly different from my two arc, and that's why we use different ticks, a different number of ticks for those guys. Now, last but not least, in the angle section is bisecting an angle. Hey, we just did that with a segment. So remember, bisect means cut in two or cut in half, just like bisecting a segment. So we might have something like this. We'll use our A, B, C, D thing. You might be told something like BD. Oh, you know what? This is not a line, is it? It's got a start point and it goes forever in one way. We call that a ray. So again, you kind of just take that thing right above BD. So we'd say BD or ray BD is an angle bisector. I spelled wrong. Boom. So if we know that, then we can say, hey, if this cuts the whole angle in half, then we know these guys are congruent. ABD is congruent to DBC. Boom. And you will use that to set up and solve equations. You might have something like, hey, if this is x and this is 48, what's x? Something like that. Again, please refer to the examples videos. We'll go through a few of these together, and that will give you a picture for how to use these with algebra. So again, thanks for coming, thanks for watching, and I will see you guys in the lessons video.